Alright, hey everyone, it's Mr. Mulford. I am going to run you through today on how to sketch graphs of quadratic functions in two different types. We're going to look first at vertex form, which in my opinion is the easier one to work with, and then we're going to look at one in standard form. One of the ones we're going to look at will be one that's downward facing, and then one we'll look at will be upward facing. So let's start off with the vertex form, which again, in my opinion, is the easier one to work with. So let's say we've got the function f of x equals, let's go negative 2x minus 1 squared plus 4. The first thing I want to do from this equation is pick out two things. First of all, what's the vertex? And second of all, how is it going to open? The vertex I can find from the equation right here. The quantity that's in parentheses, the x minus 1, will tell me the x-coordinate of the vertex. And it's going to be the opposite of whatever number is there. So because it's a minus 1, my vertex is going to have an x-coordinate of 1, and my y-coordinate will be the number that's right here. That's representing the vertical shift of the quadratic function. So the vertex will be at 1, 4. So I'm going to go ahead and put a point there just because kind of a reference because I know that that's where I'm going to need to be. I will look at next the concavity of the graph. Does it open up or down? And I can tell that number from what's in front of the parentheses. Because this one is a negative 2, that tells me the graph is going to be concave down. I should expect my graph to open down. I don't know that for a fact. I'm going to verify that with a table to make sure that everything is correct, and we'll see how everything goes. So I've got x, and I've got f of x, and usually with a quadratic function, there's some awesome symmetry going on here that everything on the left and the right of the vertex are mirror images of each other. So if I can start with a middle value and then find a couple points on either side, then I can get a pretty good idea of what the shape of the graph is going to be. And I've got, let's see, 1, 2, 3, 4. I think I need one more point here. That gives me enough. So in the middle, I'm going to put my vertex, which we know is at 1, 4. So my next step is going to be take a number to the left and to the right, one away from 1. I think that's probably the easiest thing to plug in. So we'll put a number like 0 and a number like 2. Here's the awesome part. I don't actually need to plug both of those numbers in. I can pick one, and then I'll have a mirror image on the other side. So I'm going to go with the easiest one in this case, I think, is plugging 2 in. If I plug 2 into the original function, I'll have 2 minus 1, which is 1. Cool. Square that, I still get 1. Multiply by negative 2, I get negative 2. And then plus 4 gives me 2. So I should be going through the point 2, 2. And also on the other side, and if I need to, I can verify and plug it in. But I'm also going to get 0, 2. So I'm going to plot those points 0, 2, and 2, 2. I'm going to go one more in either direction. So I'll go with a 3 and a negative 1. And I think, again, 3 would be the easiest one to plug in. 3 minus 1 is going to be 2. 2 squared is 4. 4 times negative 2 is negative 8. Plus 4 is negative 4. So I'm going to go to the point 3, negative 4, and I've got a mirror image on the other side. So 3, negative 4, negative 1, negative 4. And so those are the 5 points I'm going to use to give myself the graph. And it does look like it does open down. So I'm going to connect those points right here. That's not a great looking quadratic, but it's a general idea of what the shape of the graph is going to be. It looks like I've got 5 accurate points. It does open down. My vertex looks to be accurate as well, so I'm satisfied with that equation. I'm going to graph another function now in standard form, which again is going to change things up a little bit and make things a little bit more complicated. So on this one, I'm going to go with the function 2x squared plus 8x plus 10. Now, picking up the vertex is far more complicated. It wasn't a matter of changing a sign of what's in parentheses and just grabbing a number. To find the vertex, I'm going to have to find effectively where the axis of symmetry, where the center of this parabola is going to be. And to do that, I'm going to use the relationship that's going to happen at the opposite of b over 2a, which is related to our quadratic formula, but it's essentially, telling you where the middle of the parabola is going to be. So I can take my values, my opposite of -8, or sorry, of 8, not -8, but of 8 would be -8, and 2 times a would be 2 times 2, so we know that's going to be 4. My x value will be at -2. From there, I can find the output, the y coordinate. And I'm going to do that by plugging -2 into my function. So I will do 2 times -2 squared plus 8 times -2 plus 10. So this whole quantity right here will turn into 4 times 2 is 8 minus 16 plus 10, which gives me 2. So that tells me my vertex is at -2, 2. And because this a value is positive, that tells me my graph should open up if I've done it right. And we're going to find out here in just a minute. So I'm going to set up my table. Again, I've got 5 values that I'm looking for. So x and g of x. 1, 2, 3. I need 4 lines to create 5 values. I'll start in my middle, which was -2, 2. Just like we did in the last problem, I'm going to pick a number that's smaller than -2, so -3, and one that's bigger than -2, so let's go -1. I think -1 will be the easier one that I want to plug in. Plugging it into the function, I'll have -1 squared, that's 1, times 2 is 2, plus 8 times -1, that's -8, so I've got 2 minus 8, which is -6, plus 10 is going to give me 4. So I should have values at 4 for each of those. So go to -1, 4, and -3, 4. Going one step further, I think 0 would be a nice easy one to plug in. I don't want to plug in -4. When I plug 0 in, I would have, well, that 0, and that 0, and I'll get 10. So I'll go to 0, 10. I'll go to -4, 10. I'm going to try that again. That was off. My goodness. Jeez. There we go. That's a little bit better. So that's the sketch of our parabola. Again, there are more points we could use, but there's a couple issues that we're going to run into. As we go further and further out, our numbers get very large, and we're really not going to be able to fit those on the grid, which could be a concern. There's some patterns you might notice. You might notice that in our original here, from our center, we went up 2, and then we went up 8 from the original. That has to do with the relationship with the quadratic. So there's other patterns you can kind of take a look at, but I think the easiest thing to do is find the center, find the vertex, and then plug in points on either side. Once you've got that, then you get your 5 accurate points, and your graph kind of takes shape from there.